Okay, so I want to take a moment to have a look at the expansion of this pair of brackets. Let's go through the normal process then. So it will be a multiplied by a first of all, will give us a squared. And then we've got a multiplied by negative b, so a positive multiplied by a negative will give us negative ab there. Then we'll have b multiplied by a, so two positives, so it's going to be positive ba. And then we've got this positive b multiplied by this negative b, so it's going to be negative b squared. Having done that, this now then gets a little interesting. If we look at these two terms in the middle, we can see that they're actually the same as each other. We've got AB, so that's A times B, and we've got B times A. And as we can multiply in any order, that B times A is the same thing as A times B. So that's minus AB plus AB, which of course just cancels out to 0. That leaves us then with A squared minus B squared. Now this is interesting because we've expanded some terms from these brackets where we've got terms in A and we've got terms in B separately. And because of the way it's set up with this positive here and this negative here and otherwise symmetry between these two brackets, all of the combined terms, all of the terms that have both A's and B's in, cancel out. And we're left at the end with something then that's A's all on its own and B's all on its own. This is not just interesting, this is actually a very important result. Let's write it out again. I'm going to write it out in the other order actually. So a squared minus b squared is the same thing as a plus b times a minus b. This is a very important result here, and it comes up all over the place in higher level mathematics for simply solving problems. Because the idea is now that we've got this result, we don't have to go through that whole process that I went through up here, expanding the brackets out. We know that any time we see either an expression in the form of the left-hand side of the equation or an expression in the form of the right-hand side of the equation, we can rewrite it as whatever was on the other side of the equation. We've got a name for this rule here then. It's called the difference of two squares. And very simply because if you look on this left-hand side, we've got a squared, so that's one term squared. B squared, so that's a second term squared, so we've got two squares there. And then we're subtracting one from another, or we're finding the difference between the two. So it's the difference of these two squares. And so if we have anything in this format, something squared minus something else squared, then it factorizes into this format, the two things added together, multiplied by the two things subtracted one from the other. Just waiting for some cars to go past. Let's have a look at this in practice then. So here we have an expression, and it's a little bit of a complicated one, but actually we can look at it and see that it is two terms squared. So we've got on this side 9x squared. If we look at that then, what I'm saying is that's the same thing as the a squared that we had in our rule previously. So if a squared is 9x squared, what that means is a, if we square root this 9x squared, square root of 9 is 3, and the square root of x squared is just x. Okay, so 9x squared is effectively the same thing as 3x squared. Similarly, the 16y squared, I'm going to call that b squared for a moment. I'm saying b squared is the same thing as 16y squared. And then if we square root that, we've got b on this side is equal to the square root of 16, which is 4, and the square root of y squared, which is just y. So again, going back into this form here, we're saying we've got 3x squared minus 4y squared. And so this isn't exactly the form that we had for our rule for the difference of two squares. Let me write it out again over here. So we've got a squared minus b squared is equal to a plus b multiplied by multiplied by a minus b. So that was our rule, a squared minus b squared equals a plus b multiplied by a minus b. And so now for this expansion that we've got here, if we're saying it's 3x all squared, that's the same thing as that 9x squared, our a is 3x, our b is this 4y, so we can go from that form here to having it now instead in the form a, which is 3x, plus b, which is 4y, multiplied by a, 3x again, minus b, which is the 4y. And so that form that we have here is our factorized form of that original expression 9x squared minus 16y squared. Like I say, this has all sorts of uses at higher levels, so it's really well worth recognizing.